We're going to look at evaluating numbers that are raised to fractional indices. Now, in order to start doing this, we need to know the basic rules of fractional indices. If we take y to the power of n times y to the power of n, y can be written as y to the power of 1. Using our index rules, when we multiply indices, we have to add the index. So here, n plus n is equal to 2n, and we know that this is equal to this 1 here. So 2n equals 1, which means that n is equal to 1/2. Now we have something that when you multiply by itself gives you the original number. This means that y to the power of a half is equal to the square root of y. If we look at a similar rule, y to the power of n times y to the power of n times y to the power of n equaling y. Again, we've got y to the power 1. So our indices rule again tells us that n plus n plus n must equal 1. So 3n is equal to 1. So n is equal to a third. And this means that we've got y to the power of a third is the cube root of y. So in general, if you are finding y to the power of 1 over n, that tells you the nth root of y. So if we've got 4 to the power of a half, that means the square root of 4, which is 2. If I've got 8 to the power of a third, that is the cube root of 8. So I have to find out what number do I times 3 together to make 8, and that's 2 times 2 times 2, which is 8. So the cube root of 8 is 2. Looking at 16 to the power of a quarter, that is the fourth root of 16. So I need to find a number that I times 4 of them together to make 16. 2 times 2 times 2 times 2 is 16. So the fourth root of 16 is 2. 27 raised to the power of a third gives you the cube root of 27. So 3 times 3 times 3 is 27, so the cube root of 27 is 3. You should always be suspicious when you're asked to calculate these in a non-calculator paper. They will be numbers that will be equal to the suspicious numbers because they're square numbers that are made by squaring whole numbers, cube numbers that are made by cubing whole numbers. So you may find that the numerator is not always going to be 1. If we take, for example, y to the power of 2/3, this is where we need to use another rule of indices, where if we take y to the power of a third and we raise it to the power of 2, or square it, then these two indices here are multiplied together to give this index here. So it's a case of actually looking about which is easiest to do. Here you've got a cube root and a square. This third tells us we need to cube root, and this 2 tells us we need to square. Doesn't matter which order we do it in, so we work out the easiest way. So if we take 4 to the power of 3 over 2, we can either cube 4 and then square root the answer, or we can square root 4 and then cube the answer. Doesn't matter. So I know that the square root of 4 is 2, so I'm going to find out the square root of 4, which is 2, and then cube it, and 2 cubed is 8. So it's worked out very straightforwardly. It will also give you the same answer if you were to cube it and then square root it. If I take 8 to the power of 2/3, I'm suspicious here because 8 is a cube number, so I'm going to work out the cube root of 8 and then square it. The cube root of 8 is 2. I square that, which gives me 4. And then I've got 25 to the power of 3 over 2. I know the square root of 25, so I'm going to work that out first. and then I'm going to cube it. 25 to the power of a half, or the square root of 25 is 5. 5 cubed is 125. So in general, when you have a power that is a fraction where the numerator is not 1, this means we find the nth root of y and then raise it to the power of n.